Well, if the ending of the first session is any indication, I'd say we're in for a treat in exploring sleep at a national level. It is my sincerest pleasure to welcome Dr. Marishka Brown to the 60th Nobel Conference here at Gustavus Adolphus College. With a PhD in pharmaceutical science and the completion of a postdoctoral fellow that involved investigating the role of unfolded protein response in age-related sleep changes, Dr. Brown's experiences have contributed to her expertise in advancing the state of science around sleep for our nation's health. As the director of the National Center on Sleep Disorders at the NIH, Dr. Brown leads a robust research agenda related to sleep and its impact on health and wellness through a variety of lenses. Since 2016, Dr. Brown has been contributing to the development of a dynamic portfolio of research at the National Center on Sleep Disorders, revolving around sleep medicine and sleep disorders. Sleep health encompasses the dimensions of duration, efficiency, timing, regularity, alertness, and quality of sleep. Sleep health disparities are differences in one or more of these dimensions on a consistent basis with significant adverse effects on designated disadvantaged populations. Through her role at the National Center on Sleep Disorders Research, Dr. Brown prioritizes initiatives that integrate a variety of research approaches and study designs that lead to a better understanding of sleep health disparities, causal pathways, and sleep-related mechanisms. Not only does this research lead to better understanding of these disparities, but also has the intent to inform sociocultural appropriate interventions and support. From continuing to explore the detailed physiological structure of sleep, to advancing the knowledge related to the impact sleep has on sociocultural and economic levels, Dr. Brown is dedicated to supporting scholarly endeavors that have a positive impact on health and safety outcomes for our nation as a whole. Please help me in welcoming Dr. Brown as she provides context around the NIH Sleep Research Plan that aims to advance sleep and circadian research.
So I'd like to thank Heidi very much for that introduction, and thank you so much to the faculty and students and community of Gustavus, because it has been fantastic and amazing to be here. You all have been extremely welcoming. And today I just want to talk a little bit about my office and NIH in general. Show of hands, how many have heard of the NIH? Awesome! Second question, before the COVID-19 pandemic, how many of you have heard of the NIH? See, still great numbers. And so I'm going to tell you a little bit about NIH, my office, who we are, what we do, and some of the lovely people that you've already heard of whom we support in the research that we cover. And so today I'm going to give a little bit of an overview. I'm going to, again, talk about NIH and then the National Center on Sleep Disorders Research. Most of our investigators, the National Center for, I was like, no, it's on, it's congressionally mandated, it's the language. Sleep and circadian biology and health and disease, and you've heard a little bit touched on by Bob and by Amita this morning. And then I'm going to talk about our NIH Sleep Research Plan. So we support sleep and circadian research, but we do have priorities and what we consider as timely and actionable items that we hope the investigative community comes into to kind of understand what's happening and what's going on. And so the National Institutes of Health, it has an S on there, the NIH, this is our lovely clinical center, and Bethesda is the National Medical Research Agency. It is located primarily in Bethesda, Maryland, even though there are satellite campuses across. But this is our lovely clinical center, which is a hospital located on the NIH's campus. It's not a hospital that you can just walk into. Everyone who comes to this hospital has an appointment, and they work with the most rare, the most complicated cases for scientific research and discovery. And so if I fell out in the middle of NIH campus, they would take me to Sibley. They would not take me to clinical center. And 80 to 85% of the NIH budget goes to research that's outside the NIH. And a lot of people don't know that. We, right now, I think, have a $43 billion budget. It seems like a lot of money until you look at the DoD's budget. But 80 to 85% of that goes to universities and hospitals and small businesses. And only about 10% of that budget is what we call intramural. So NIH does have researchers and faculty that are on campus, and that is a smaller percentage of their budget. But most of the money goes to the domestic US. And I wanted to highlight for those who may not know that we did have a new NIH director confirmed or appointed in November of 2023. Francis Collins was our longest serving NIH director, and he stepped down, and we just got Monica in December, and she is working some magic, and hopefully we'll be able to have her around for a little while longer because she is from a rural area. Primary care, rural health is something that she's very passionate about, and we would love to see what she's able to do with that. And so the National Institutes of Health, there are 27 institutes, centers, and offices at NIH. And these are all the small acronyms. In the middle, it says OD, so that's the Office of the Director. They think that they're the center of the universe, but actually they're not. But they love this graphic, and they're in the middle arbitrarily. And where I work is NHLBI, the National Heart, Lung, and Blood Institute. And the National Center on Sleep Disorders Research is hosted within there. And some may wonder, why is the Sleep Center in the Heart, Lung, and Blood Institute? Well, it's two reasons, really. One is political, that at that point, NHLBI was one of the larger institutes, is until recently, when National Institute on Aging, with the Alzheimer's set aside, their budget is much larger than ours now. But by personnel, it is number 4, and by budget, number 3. We're at about a $4 billion budget. But pulmonary research and sleep apnea, which affects pulmonary, which is why the Sleep Center is in the Heart, Lung, and Blood Institute. And so the Heart, Lung, and Blood Institute is the nation's leader in heart, lung, blood, and sleep disorders. And so if you talk to any of the insiders at NIH, they never say HLB, heart, lung, blood, they say HLBS, because sleep is certainly an institution there where we are. And so a little bit about the origin of NCSDR. We are congressionally mandated. Congress said that we must exist. And what happened was the sleep and circadian communities came together, and Mary's in this room, and I hate that I don't have a picture of her, down with Bill Dement, going down to Congress, advocating for the development and the creation of the center. And so in 1993, there was this national commission, Wake Up America, that really talked about all of the negative health consequences that were related to sleep apnea and sleep disordered breathing. And so this is our code, and essentially you can summarize NCSDR and what we do into 3 buckets. We support research. We are the largest funder of sleep and circadian research in the world. Historically, even though, again, the National Institute on Aging, or NIA, is sharp on our heels because of the Alzheimer's set aside, but currently we are the largest funder. We also coordinate across not only the NIH, but across the federal government, and then education, events such as this, where we tell the public, talk to researchers, and disseminate the information that our investigative community develops to tell you about the exciting science and research that we support. In addition, we have a FACA committee, or a Federal Advisory Committee, the Sleep Disorders Research Advisory Board, which essentially is 12 members, 12 appointed members. We have researchers across many different stages, from established to early career. And then we also have 4 what we call public members. And they are members who either have a sleep or circadian disorder themselves, or they represent a society or a foundation. And they really are our pulse to what's happening in the community, because we can only know so much. And so we get our feedback from this board. And these meetings, the board meets 3 times a year. The meetings are open to the public. They're virtual. And so I'll have information at the end to let you all know. If you want to log in and listen to what we have to say at those meetings, feel free to. And so for coordination, we have several components that we do. We have an NIH-wide Sleep Research Coordinating Committee. And this coordinating committee is comprised of about 17 or 18 different institutes, centers, and offices at NIH. And there are program officials who hold sleep and circadian biology and research in their portfolios. And as the director, I'm the chair of this group, and we come every month, and I talk about what's happening, what are your initiatives, what activities, what workshops, and we come together to discuss what are those hot topics, what's the bleeding edge in there, and where we get the bleeding edge is not from us sitting around a table having a conversation, but it's talking to the investigators, and someone talked to you about a different project that they want to do. Is this something that we should be stimulating? Or we went to a meeting and there were conversations around a certain topic, and we want to grow these things, and so we really listen to our community, and how we speak about our role is NIH leads from behind, because we are really listening to our community and our investigators about what are the hot topics, what's the next thing to happen. We also coordinate across the federal government. We work with the Department of Transportation, the Department of Energy, our sister agencies with the CDC. We work with also the U.S. Department of Housing and Urban Development, which is actually a new collaboration that we've been working on. And why would we work with HUD, right? Because most people, the house is where you sleep. Right? And how that environment impacts your sleep. And for HUD, for a long time, their priority was about the asset. It was about the property. And then with their last secretary, the interest was, well, what about the people who are living in those properties, right? And so then we started getting involved with them and are, developing some potentially programming around in coordination with HUD. And so when you think about the pillars of health, when you ask them about health, everyone knows about getting exercise, physical activity. Everyone knows about proper diet and nutrition. But I want to challenge and say that actually sleep is the third pillar of this, because sleep is underlying a lot of these things, right? If you do not get proper rest, then you might not feel like exercising. And we know from the research, and a lot actually started with the Department of Defense, where if you are sleep deprived, you make unhealthy food choices. So you can have all of the nice fruits and vegetables and salads in front of you, but you're going to carb load, right? And that was beautiful research that started in the military, and we know now from the research that it's not just what you eat when it impacts obesity, it's when you eat. Right? That is really something that we are supporting right now in that research space. And so sleep is in the same category as nutrition and physical activity, but it also can be analogous to air and water. And as Bob mentioned earlier when he was talking about his results, or the results earlier in rats, when they're sleep deprived for a long period of time, they die. So there is something that sleep is doing, a lot of things that sleep is doing that is managing optimal health and well-being. And so Amita talked about Drosophila melanogaster. It's one of our favorite models. But sleep can be observed across species, and there's something that's evolutionarily conserved about sleep. And most of the species that we've looked at, they found some form of sleep, and that's the roundworm C. elegans, it's human babies, it's squirrels, puppies and kitties and dolphins who have unihemispheric sleep, and you have cats that have polyphasic sleep, where they sleep throughout the day, but all of these organisms are sleeping. And as Bob mentioned, the brain doesn't turn off during sleep, right? There used to be a myth years ago where it says people only use 10% of their brain. I was like, that's the dumbest thing in the world, right? You use all parts of your brain. There's parts of the brain for walking and eating and, doing and breathing, right? All of these parts. So your brain is working continuously. And so it doesn't turn off. It just switches to a different organization in a change in behavioral state. And you have reduced response to surrounding, and Amita talked a little bit about that earlier when they were talking about characterizing Drosophila sleep. But again, the sleeping brain works just as hard as your awake brain. And I won't get into it today, but you can look up some beautiful papers by Cliff Saper, where he has his flip-flop model that talks about the changing organization of the brain when it's asleep and awake. And so Bob showed something similar, which is a hypnogram. But sleep is very dynamic, right? It changes throughout the night. And you have the sleep, and you have all of these different cycles during sleep. And these cycles take about 90 to 120 minutes to complete each cycle, right? And so when we talk about being healthy or sleeping that recommended 7 or more hours a night, that's so that you can complete all of these cycles. Because if you don't sleep that many hours, then you start undercutting these hours, which seriously undercuts your health because you're not completing all of those cycles. And so Amita talked a little bit about this, being our card-carrying circadian biologist in the room, where these circadian rhythms we develop in sync with the sun and the rotation of the earth, right? That's why the rhythms is about 24 hours, because that's how long it takes for the earth to rotate to a full rotation on its axis, right? And so we have these signals to our brain, and they're called zeitgebers or cues, and light is the strongest signal for circadian rhythm. But you also have your feeding schedules, which impact peripheral clocks. You have these physical activity, and so you have this central or this master clock and this part of your brain called the suprachiasmatic nucleus. And that master clock actually somehow syncs or works with all of these peripheral clocks. And these peripheral clocks are in your cells and organs throughout the body. Pretty much every organ in your body has clocks, right? And all of these things are working together to maintain balance and maintain homeostasis. And again, as Amita mentioned earlier, there was the 2017 Nobel Prize in Physiology or Medicine with the discovery of these circadian rhythms. And so there's essentially a process, a Borley model of this is called the two-process model for sleep and weight regulation. And so you have this circadian process, which is called process C, which is these intrinsic rhythms that are underlying many of our systems: metabolism, immune system, almost any system you can think of is circadian gated or circadian controlled. But then on top of that, you have the homeostatic process or the sleep drive. And when they are perfectly aligned, then things work well. You get up refreshed, you're functioning, your body is working well, everything is in sync. It's like a motor, right? Where you have all the cylinders are firing, everything properly, or even an orchestra, right? Where you have this beautiful synchrony. But if one or two of those players are off, which happens when you're chronically sleep deprived, your rhythms then become misaligned. And so you have all of these challenges that come when your sleep and circadian system are not in proper rhythm. And so Amita showed a similar graph earlier, or a pictorial graph earlier, where you have all of these processes, and only a few of them listed on here, where you have rise in blood pressure, the best time for coordination, the lowest body temperature, your deepest sleep. For those who may not know, or maybe I'll pose the question, who knows when heart attacks are at their highest? I know, Amita, I know you know. There's one person in the back. Kind of in the morning, right? And so because you have these spikes in blood pressure when you wake up, that's when most of the heart attacks occur. And all of that is circadian regulated, right? And so in addition to the sleep-wake cycle, which is a circadian rhythm of itself, you have circadian rhythm controlling insulin secretion and stress response and lipid absorption. When you think about metabolism of drugs, that is circadian gated, like in your liver, and all of these things are controlled by these systems. And so everything is on a time. We know that we have the time on the clock, right? There's the wall time, but we also have the timing that's within our body that's controlling all of the things that are happening. And so sleep deficiency is really prevalent in the US. And so this data is from 2022. It's the CDC Behavioral Risk Factor Surveillance System, or BRFIS. And this is when you hear people say that about a third of American adults, are not getting sufficient sleep. This is the CDC data. And these numbers have been steadily increasing higher and higher, where you are ranging from 30% in some of these states all the way to up to 50% of the adults, and they're characterizing adults as 18 or older, who are not getting sufficient sleep. And when you don't get sufficient sleep, individuals who sleep fewer than 6 hours a night, this is a little bit older, is 13 to 15% higher at mortality risk than people who sleep at least 7 hours a night. And so we know that sleep is providing many, many vital functions. And there are some that were listed earlier. We talk about learning and memory, but all of these peripheral processes that sleep is somehow impacting. And so poor sleep and sleep disorders increase medical risk, increase in hypertension. And I'm looking at this I listed not only just sleep deficiency, but obstructive sleep apnea. That's where you see OSA, that's sleep apnea. And when you see AHI, that's apnea-hypopnea index, that's essentially the diagnostic criteria that's used for sleep apnea. And so if you have a low AHI, less than 5, that's mild sleep apnea. If you have an AHI greater than 5, or it's characterized mild, moderate, and severe. And so this just showing if you have a low AHI, you have, or a AHI that was between, I think, 1 and 5 for this data, you have an increased incidence of stroke, but if you have AHI greater than 5, that incidence of stroke goes way up. Dementia, this data is actually from Nora Volko. She is from her lab. She is the director of the National Institute of Drug Abuse and is actually very, very interested in sleep. And what they did was they took adults into their lab, sleep deprived them for one night only, and saw an increase in these amyloid beta levels. And so, as Bob mentioned earlier, there are 2 histopathological hallmarks for Alzheimer's disease. One is amyloid beta, one is neurofibrillary tangles, and so just one night of chronic sleep restriction. And so just think about, years of chronic sleep restriction, because when you think about something like Alzheimer's disease, by the time you become symptomatic, it's too late. Right? By the time you go into a physician's office and they can diagnose that, then that's years of pathology. Same thing with diabetes, increased obesity risk. All of these are outcomes that have been linked to sleep deficiency or sleep disorders. But the good thing about it, right? We're always talking about the bad news of when you're not sleeping well. But this is research that we've been supporting over the years, is that if you have good, healthy, good quality sleep, at the right time, getting enough sleep, then you can prevent increases in blood pressure. You can decrease obesity risk. You can improve insulin sensitivity, improve cognitive performance. There is a lot of research going on right now. I know I keep mentioning Alzheimer's disease and dementia, probably because of the $600 million set aside that they get a year from Congress. And so research in that space has exploded. And so we're seeing a lot of that happening in the sleep and circadian space. So we're happy about it. No complaints for me. But there's a lot of research, active research in the area, as well as showing that if you have good sleep, improving sleep lowers stroke risk, and targeting sleep actually improves motor recovery post-stroke. And all of this is in human data. And so when we talk about these things, I've been mentioning adults for the most part, but sleep restriction or sleep deficiency across the lifespan has serious implications across the lifespan, whether it's in utero or childhood and adolescence or in later adulthood. And there have been studies that have shown that if a mother is sleep deprived, that it impacts brain and lung development, that when you're looking at childhood, if they are sleep deprived or getting insufficient sleep, then it increases weight gain, it impacts their cognitive development. And so when you're thinking about, children and adolescents when they're in school or when they're not getting proper sleep, then it impacts performance. And when you're impacting performance, that changes or potentially could change the trajectory of the rest of someone's lives. And so there are many, many different directions and opportunities for sleep research. And I made these, it's sun and a moon. Sleep and wake, even though we're talking a lot about sleep, unraveled, what we're really talking about is sleep and wake. Because we really care about sleep partly because of the function and the process and what happens, but we're really seeking quality wakefulness, right? And so that's one of the things that we're quite interested in. And so I took this from 2022, took all the titles from all the awards that have been funded across NIH and put them in a word cloud and came and saw kind of some of the activities and things that we were supporting in that space. And as you can see, sleep and circadian, of course, are the biggest. And so I want to transition a little bit to our NIH-wide sleep research plan. And so when you're thinking about opportunities and you want to have a strategy, right? Because you can support everything under the kitchen sink, which we do, right? We are not trying to impact any investigator coming in with a meritorious application. We do want to see all awards that come in, but again, with only $43 billion, we can't support everything. We get almost at this point 90,000 applications a year, and we support anywhere between 10 to 15% of those. And so outlining particularly high priority areas of interest, and this wasn't Marishka sitting down at her desk thinking, what are the high priority interests of sleep and circadian? No, this was a years-long effort where we worked with our Sleep Disorders Research Advisory Board, where we went out and we talked to the community at conferences, where we had an idea scale where people came in and they wrote in their ideas, and we vetted them through not only the sleep and circadian research community, but our leadership, and then we outlined this plan. And with this plan, we have 5 goals that we're looking at, and they are pretty broad, as they're meant to be. But these goals are essentially the backbone of this plan, where we're trying to understand the underlying mechanisms of disease, all the way to goal 5, fostering the development of a strong and diverse sleep and circadian workforce. And even though it's goal 5 and it's listed last, if you're thinking about a pyramid, it would be on the bottom, but it would be the biggest thing, because all the work that we want to do cannot be done without the properly trained workforce and staff. And so we're always very interested in inquiring young minds and not so young minds to come into the sleep and circadian field. And it's not, when we speak about diversity, it's not just physical diversity, it's diversity of ideas, different disciplines, engineering, informatics, all of those people coming in, because we know that they can contribute to the science. And in addition to these 5 goals, we also have high priority research areas and tactics, as well as these 9 what we're calling critical opportunities. And those critical opportunities are what we consider timely, actionable items that we can see a real impact in the next 5 to 10 years. And so we have this plan, and we don't want it to sit on the shelf, right? And I put the link down because when we developed this plan, you can download it, but it's really meant to be a digital-first strategy where you go in, we have these nice, pretty pages, and you can go and play in and look and see kind of what we're interested in doing. But we don't want it to be something that sits. It really is about taking this plan and implementing it and having the researchers come in and say, okay, this opportunity fits what I'm going to do, or yes, I do think this is a high priority. This is something my lab is working in. I'm collaborating with this person and really moving the science forward, because that's what it's about. It's about the breakthroughs and making sure that we are moving these research areas, both sleep and circadian biology, forward. And so I just want to talk about a few of the things that we're doing to do that, particularly translation. And part of one of the things that we're working on now is addressing the opioid public health crisis in the US. And so Congress has funded a program called Helping End Addiction Long Term, or we call it HEAL for shorthand. And it really, it was launched in 2018, and it's really a pretty aggressive effort. And when we say aggressive, that means that Congress put a lot of money behind it. In the first several years, it was almost $1 billion put into this effort to really try to get to the bottom and really find the bottom of, and to find useful strategies to help people and to address this opioid epidemic. And so we were able to work in this space because there had been research that laid the groundwork that showed that there was this relationship between sleep and addiction, or opioid use disorder, that people who were in the midst of disorders, first of all, they were chronically sleep deprived, but also if you essentially there was research that showed that if you help people sleep, then it could actually help them manage in some ways better that addiction. And so we have several studies that we put out, or several funding opportunities that we put out to address mechanisms, sleep and circadian dependent mechanisms that were underlying opioid use disorder. We had supplements to look at these OUD treatment responses and recovery outcomes, and looking at how sleep impacted that. And so we are also looking at recently the connection between sleep and pain and opioid use disorder. We actually have a workshop that's being planned for December where we have some world-renowned pain investigators coming to work with sleep investigators to figure out how, first, underlying mechanisms, because for the basic biologists, and there's still a little bit of a basic biologist in me, wanting to understand that why, but overall, what we do is about helping people, and it's about advancing medicine and public health. So sleep and the health of women, something that is really close to my heart, because even though women are half the population, when you think about medical research, research in general, but particularly medical research, females were totally ignored. And even in 2016, NIH actually put out a policy called Sex as a Biological Variable. And they told the research community, you can no longer come in with an application that looked at males only, that we need to understand what was happening in the female. You would not believe how much blowback we got from this, because you would have investigators that say, but females are complicated. Yes, the estrous cycle confounds everything. Or maybe the estrous cycle is uncovering what's happening in the female body. Right? But now it's actually a criteria that's discussed in review, that you have to write how you're going to discuss sex as a biological variable. So if you come in with an application that is only males, it has to be a scientific reason. You can't just say females are complicated, which unfortunately flew for a very long time, but that doesn't fly anymore, right? And so I wanted to highlight, we actually had a conference in 2018 on sleep and the health of women, and I put that here because in the next couple of years, we'll be updating the research in that space because it has really exploded, and we're really interested to highlight and showcase some of that new research in sleep and the health of women, because we understand that sleep does change across the lifespan. And again, sleep happens with an individual, but it also is impacted by society and your environment and all of those things. And when you're thinking about the lifespan of a woman, not just in childhood, not just reproductive and pregnancy years, but sleep and pregnancy is a whole different animal that we're exploring, but also perimenopause and aging and what that looks like and how that changes sleep and how that changes the interaction or the prevalence of disorders such as obstructive sleep apnea in women. And because I am in the Heart, Lung, and Blood Institute, just wanted to highlight some of the things that we've been doing in sleep apnea and maternal cardiovascular disease. And so maternal morbidity and mortality, for anyone who has been reading the news, it is a hot, hot topic. And the reason it's a hot, hot topic, because for the US, which is one of the most developed countries in the world, we have one of the worst infant mortality and female and maternal mortality rates in the world. So how can you be one of the richest, maybe the richest country in the world, and you have women still dying in childbirth at rates for countries that are far less developed than we are? And so we want to understand that. And so we've been looking at how sleep-disordered breathing or sleep apnea impacts not only women, but also the child. And what we found with some of these studies, and I just highlighted a few, was that sleep disordered breathing or sleep apnea actually increases the risk of preeclampsia and gestational diabetes. And so I spoke earlier a little bit about AHI, the apnea-hypopnea index, and that, to have a clinical diagnosis, you have to have apnea-hypopnea index around 5 or greater. But in pregnancy, you see apnea-hypopnea index that are much lower but have severe outcomes, right? So pregnancy is a different beast. And so what was happening is you would have women who would go and say they were having these challenges, but they were not getting treated because they did not reach a clinical threshold. So we're trying to change that, or we're trying to persuade medicine to change that, right? And by doing that, by developing the evidence to do so. We have another study that was the Heart Health Study, and it's New Mom to Be. We always like these cute acronyms and these names. And it was looking at adverse pregnancy outcomes that are linked to the future cardiovascular health. And so when they had sleep disordered breathing in pregnancy, not only did it lead to these pregnancy-related outcomes with preeclampsia and gestational diabetes, but later cardiovascular disease. And they only had the apnea during the time that they were pregnant, which is a short period of time. And so what are those underlying things that are happening that are leading to these future adverse outcomes? And then I wanted to point out something that we're doing now. MFMU is Maternal Fetal Medicine Unit. So the NICHD, or the National Institute of Child Health and Development, which I put all of these acronyms and did not explain them. All of these are institutes and centers at NIH, but they have this huge US-wide network that's called the Maternal Fetal Medical Unit, and that's how they do their clinical trials. And so we're actually partnering with them to do a sleep apnea clinical trial to essentially see that if we treat sleep apnea or sleep disordered breathing in pregnant women, will that alleviate those negative outcomes? And so we're keeping our fingers crossed. They were enrolling about 1,800 women. I think they're about at 1,200 women now. And so within the next 2 or 3 years, those results are coming out. And this trial is extremely important. And OBGYNs are watching it very, very closely, because this is one of those things that actually can change clinical practice. So when we talk about treatment of sleep disordered breathing or sleep apnea, lots of people have heard of continuous positive airway pressure, or CPAP, right? But that's not the only option when you're thinking about sleep disordered breathing. And when we're talking about personalized, it's based on what works for you. And sleep CPAP does work, right? Essentially, it maintains airway patency, but a lot of people can't adhere to it. They're not compliant because for some reason or another, it just doesn't work for them. And so what you want to do is you really want to give people options. And so what we do we support research to kind of see these different treatment options for people. And so in addition to supporting research into CPAPs and adherence and increasing adherence in certain populations. I just have a cute picture of a little girl here actually she has Down syndrome, and I'll talk about that a little bit later because they have huge prevalence of apnea in that population. But we're also supporting studies for pharmacotherapy for sleep apnea. We're supporting studies for DICE, drug-induced endoscopy, or DICE surgery, where they're going in and they're looking at when you are a child in the pediatric population, the first line of defense for sleep apnea is usually an adenotonsillectomy. They take out all your tonsils and adenoids, or some of your tonsils and adenoids, and there are about 500,000 of those surgeries done every year. But what happens with that is sometimes they grow back. Sometimes they don't take them all out. And sometimes the origin of the snoring isn't right there in those tonsil and adenoids, the ones that they take out, but they might be in your lingual tonsils, further down, right? And so this surgery is trying to look at the place of real obstruction so that you don't have to have multiple surgeries, or you have a surgery that doesn't resolve your apnea. We're also supporting research Some of you in here might have heard of the Inspire device, which essentially is a hypoglossal nerve stimulator. And the hypoglossal nerve essentially is the nerve that controls your tongue movement. And so NIH supported all of that basic research into understanding those nerves and how they're stimulated. And now there are companies that have moved on or taking this technology to treat apnea. And so that is also something that is on the market currently. Oral devices. Now, instead of going to a sleep physician, you can go, the American Academy of Dental Sleep Medicine, they now have a society where they're going in and they can fit you for an oral device. It's slightly different because they can't necessarily diagnose apnea, but they can help you, and we've seen devices help many people who cannot adhere to PAP. And so it really does depend on the origin of your apnea and your lifestyle and what works for you for treatment. But we don't want to leave today and have people think that CPAP is the only way to treat your apnea, because there are other devices or items or approaches that can support treatment for that. And I also put a needle here. I took out the name of the company, but there have been lots of press this year about certain GLP-1 drugs for weight loss that they're saying is the next best thing for apnea. And I'm like, well, you know, if you're carrying extra weight, maybe so, but if you are a thin person with sleep apnea, that may not be a treatment option. And so another kind of space that we're interested in and understanding is the population differences in sleep disorders and sleep health. And I talked earlier about sleep and the health of women, but we're also interested in the space of sleep health disparities, which essentially is defined as a difference in one or more of the dimensions of sleep, which are listed here, that are on a consistent basis that adversely affect designated disadvantaged populations. And so when we talk about disadvantaged populations, that is inclusive of ethnic and racial minoritized individuals, but that's not the only class that is designated disadvantaged populations. Sexual gender minorities, socioeconomic disadvantaged population, and underserved rural populations are all in that protected class. And as of September of last year, persons living with disabilities is also under that class of designated disadvantaged populations. And so all of these classes experience sleep and sleep disorders in different ways. And so this is a new area of investigation for our research community. And over the past probably 5 to 10 years, it's really opened up and exploded. And we know a lot more about sleep health disparities today than we knew a decade ago. Big data. Everyone's talking about big data. People have watches, people have rings, people have phones. You have all of these things that are collecting information, whether you want them to collect information or not, right? If you think your phone is listening to you, it probably is. And so how do we use this information to be able to advance health? And so I use sleep apnea as an example because at NHLBI, we are the largest supporters of adult sleep apnea. But one of the things that we've learned about this disorder is that it's not a one-size-fits-all. It's not just you have sleep apnea or you don't. The sleep apnea is very heterogeneous. And so depending on the origin or the etiology of your apnea, that might dictate what treatment you received and how efficacious that treatment is. And actually using all of this data that we collect can help us do that. And so I wanted to highlight our National Sleep Research Resource, which is a repository that is supported by NHLBI and has, all of these data sets, thousands of PSGs. It's across the lifespan. It's a diverse data set. It's something that's open to the public. Some people, we have at least one person who submitted their own data, like they tracked their data for like 10 years or something like that, and they were able to get it cleared to put on the NSRR, but it's free and open to the public. You reach out, you download the data, and what we're interested in is how this data can provide insights into sleep and how sleep is intertwined or linked to other things like understanding the physiology of sleep, improving the accuracy of diagnosis. That's a really active area of investigation right now, how we're using big data to diagnose better people with apnea. Trying to understand and predict how people will respond to treatment, how they would adhere to the treatment. You can do that with data. Using sleep parameters as predictions of future mental and physical health. One of the things that was a paper that was published either last year or the year before that the NIH director at that time, Francis Collins, got really excited about was there was a group at MIT that used sleep data that was collected from a sleep study to essentially diagnose Parkinson's disease. And what they found was using that data was actually not only more accurate than the current test for Parkinson's, but could actually diagnose earlier. And so that made a huge splash in the news, and they use sleep data to do that. And so there's a lot in there, because when you have a sleep study, if you've seen anyone who had a sleep study, if you Google sleep study, you have all of these electrodes and patches and all of these things, because they take about 2,000, 2,500 different variables from one person. And so there's a lot of information in that. And we're now using that information to advance medicine and public health. And just wanted to highlight that we have NHLBI has a platform called Biodata Catalyst, which now some of the sleep communities and the informaticians are using, because they're linking not only the sleep data, but they're linking genetics data, and they're really trying to understand the pathology in an individualized fashion. So I wanted to talk also about this program that is relatively new. It was funded in 2018, and it's called INCLUDE, Investigation of Co-occurring Conditions Across the Lifespan to Understand Down Syndrome. In DC, we love our acronyms, and we try to make everything fit, right? And so the reason that this program existed is similar to, the advocacy of the sleep community in the early 90s to get the sleep center supported and move forward. Persons living with Down syndrome and their families, they went to Congress and they said, Congress, NIH is ignoring us, and we are being excluded from their studies. They were right. It was extremely embarrassing when we did the analysis and we looked across NIH and saw what was being funded in persons living with Down syndrome, and it was abysmal. And actually, sleep studies had explicit exclusionary criteria for persons living with Down syndrome, because it was like, well, facial malformations, they all have apnea anyway, what can we understand? And so now that is a no-go. So Congress not only developed this program, but they put their money where their mouth was in a really big way. And so we developed a research plan for funding in this space. And actually, over the past 6 years, NIH has invested over $345 million in 330 new projects for this program. So the reason that I bring this program up, particularly in a sleep space, is because persons living with Down syndrome, about 90% of them have sleep-disordered breathing. Now, that's just sleep apnea, but some of the other sleep challenges that the typical developing population experience, like insomnia, like circadian misalignment, all of those things persons living with Down syndrome experience. But we don't know, there's so much we don't know because they were excluded, right? We know so much more in a typically developing population than we do in this. And so there are things that we know that we can learn from this population that could be generalizable to the typically developing population, but we're just now starting to understand that because this program has only been going for about 6 years. And so when we're talking about, I want to jump a little bit, social determinants of health. I've said this a few times where we talk about sleep on the individual level. But again, the environment impacts your sleep. Where you sleep impacts your sleep, right? And so being able to not think about just the genetics and that individual space of sleep, but also all of these other factors that can impact sleep, your socioeconomic factors, the physical environment, the health behaviors that you do, access to health care. And so for those of you who don't know, social determinants of health have been defined as conditions in the environment where people are born, live, learn, work, play, and worship, right? And every time I read this definition, I'm like, who came up with this definition and left sleep out, right? And so They always tell me, Marishka, well, it's intrinsically there. I was like, but I want it to be explicitly there, right? But it's okay. We'll work with what we have. And so what we've been doing recently, I mentioned earlier about working with HUD, because we all know that sleep is a facet of the social determinants of health population. And addressing sleep could actually have significant impacts on the health outcomes. And so an example of this, again, is our collaboration with the U.S. Department of Housing and Urban Development, with HUD, where we're using sleep and circadian health as part of broader efforts to really improve the quality of homes and using housing as a platform for doing this. And we will have a plan or a paper that will be published, hopefully, knock on wood, next year, that highlights a lot of the webinars and roundtables discussions that we've been having with HUD, with the Department of Energy, that really highlight the research areas in this space. Climate change and health initiatives. So the climate is changing, it is happening, it is a real thing, and it has impacts on several components of health. You know, there's rising temperatures, we have more extreme weather, and all of these things drive and have health outcomes or can impact health. And so acute and chronic cardiovascular challenges are impacted by climate. We think about respiratory illnesses with the wildfires and asthma and all of those things where we have active areas of investigation, but also sleep disruption, right? When you are sleeping, typically, your body actually cools itself before you go to sleep. What if your body cannot cool itself, right? Which happens when you are in these extreme temperatures and you have fragmented sleep, and we know that fragmented or disrupted sleep or sleep deficiency leads to all of these negative outcomes. And so even though people think that sleep is oldest thing that you can get or you can't, when you think about all of those downstream consequences and all of those challenges that are impacted, it's not just this thing that you can get or not get, right? Yes, as Bob was mentioning earlier, that someone was saying they'll sleep when they die. It's like, yeah, but if you don't sleep, you might die just a little bit sooner. And so I actually like this quote. It was taken from Adam Spira. He's a professor at Hopkins. And one of the things that he was working with the community in Baltimore, because Baltimore has a lot of these row houses. And these row houses have flat tops. And all the flat tops were black, right? And so in the summer, you would have these homes where people couldn't sleep on the top floors. They would be sleeping at the bottom because it would be so hot. And so one of the things that they did, they worked with the city of Baltimore and with Hopkins to actually go in and do essentially a living experiment on, I hate to say experiment on people, but they took an approach where they decided, let's see what happens if we paint all the roofs white instead of black to try to reflect some of the heat instead of absorbing all of that heat. Well, it did make it more comfortable for the people living in those homes. They were able to go from the bottom floor and actually sleep in their beds. He hasn't published the data yet, but I like this quote because it's talking about how these high temperatures are affecting sleep quality, and it's really important to try to optimize your sleep to improve health and potentially reduce disparities. And he was very much interested in sleep health disparities, Baltimore being a majority-minority city, and really trying to understand how sleep is impacting or being impacted in these communities, particularly communities of color. So COVID, could not leave this room without talking about COVID being part of the NIH. But one of the things that's really interesting about COVID and sleep was actually one of the top reported outcomes or challenges or complications that people reported who had COVID. They either had difficulty sleeping, they started developing insomnia, all of these challenges. And so we were really interested in what was happening, not only with acute infection, but particularly with long COVID and sleep disruption as it People who typically, even before COVID, did not have sleep challenges, after their infection did. And so now we're in the midst of trying to understand sleep problems in the long COVID population. And actually, starting less than 2 months ago, they started enrolling for sleep clinical trials that are using the Recover infrastructure. One of my favorite, or maybe one of the most exciting things that I think that is happening in sleep and circadian research now is this idea of chronotherapy or chronomedicine, using your intrinsic circadian biology to optimize, whether it's, particularly when we're talking about this, it is medicines, pharmaceuticals. But, depending as far as behavioral interventions and things of that nature, depending on, your time of day, it could also be impacted. And so this is a highly active area of investigation now. Actually, at there was a scientific conference this year, the Society for Biological Rhythms, which is is the premier circadian institution for circadian rhythms. They actually had a medical course on circadian medicine, the first one. And so this is going to be something I think that people will hear about for the next few years, because when we talk about what's hot in sleep and circadian, chronotherapy is what's hot. And so what exactly is it? It's optimizing, your treatment based on the rhythm of an individual, to try to essentially maximize the efficacy of what you're doing and minimizing the side effects. And it could be a strategy to prevent or treat according to your clock, but what people may not know is that 56% of the pharmaceuticals on the market actually target circadian control genes. Right? So we talked about how the clock is in all of these systems and all of these organs, but a lot of the drugs that are on the market are actually targeting these genes. And so circadian medicine or chronotherapy is really about giving the right drug at the right time to the right person. And so we talk about sleep and circadian biology, and it's not just speaking to the sleep and circadian communities, but because this science is advancing so quickly, and because the science itself is so strong, we're starting to see uptake into different societies and medical communities. And so Life Essential 8 was developed by the American Heart Association. It used to be the Simple 7, and it was the Simple 7 for about a decade, and then Life's Essential 8 debuted last year. And I'll give you one guess what that 8 factor was. Yes, it was sleep. Because the evidence was so strong for sleep and cardiovascular prevention that the American Heart Association took sleep on and actually revamped what their structure was for prevention of cardiovascular disease. But they're not the only ones. The Diabetes Association, in their standards of care, now is listing sleep in their standards of care. When we're thinking about clinical practice, or the American Pediatrics Association, the APA, they're actually looking at sleep, not only sleep disorders or sleep apnea, but sleep health in general for obesity in children and adolescents. And so the science is advancing, it's moving, it's starting to penetrate all of these different areas. And so the questions earlier when we were talking about institutionalization and the movement of the science, it is happening, and it's starting to happen, at least I think, a little bit more rapidly. And I truly believe that we are at an inflection point where you're going to start seeing sleep being institutionalized in some of these spaces, similar to physical activity and nutrition. And so avenues of engagement with NCSDR, I am super easy to find. You Google my name and almost all of my information comes up affiliated with NIH. As I spoke earlier, we have our Sleep Disorders Research Advisory Board. We actually meet 3 times a year. These are public meetings. We meet the first Thursday and Friday in April. That meeting is in person, but we also meet the first Thursday in August, first Thursday in December. They are virtual, and you can get those links in every activity that we do. If you join our listserv, it's self-subscribed. You just type in Sleep RFA-L, and you self-subscribe. And so everything that we do, you're able to get that. We're also on LinkedIn. We have our new NHLBI sleep research pages, and this is my email contact. And as mentioned by others, no person is an island. You can't do what you do without a team, and these are the program officials that work with me in the NCSDR. And so I really wanted to thank this team because nothing can be done without them. And I wanted to end with this slide, which I've been doing for the last few years. And the reason I love it is, A, my nephew, when he was 3 years old, said that I looked like Dr. Facilier. And I don't know. He was a kid. I forgive him. But if you don't know who this is, it's the voodoo man from The Princess and the Frog, which is a Disney movie. And the reason that I use the voodoo man is because I had a circadian biologist years ago tell me about putting their application into the Allergy and Infectious Disease Institute. And they were telling me, Marishka, I can't get my application reviewed. And she said one person actually wrote in their summary statement, essentially, this is voodoo. That circadian biology was voodoo. And I said, no, circadian biology is not voodoo, but sleep and circadian biology are non-negotiable biological necessities. They're not important. They're required for optimal health and well-being. And with that, thank you all very much.